Hello, good morning, students. Here, let's start our new chapter, the ninth class, chemistry, matter in our surroundings. Matter in our surroundings only. So, in this chapter, we are going to discuss about the matter classification, physical classification, and chemical classification, and composition of matter, interconversion of matter one form to another form, and study about the properties of the matter only. So, first of all, you understand what is meant by matter. One basic idea about the matter, nothing but here, anything which occupies space, it has mass and volume, is known as matter. So remember, matter nothing but it just comes some other definition also is there. Anything which occupies space, it has mass and volume, is known as matter only. How can you say whether substance is matter or not? Suppose you just take the one glass of the water. Water, what I said in definition matter, anything which occupies space. Water molecule occupies space or not? Water molecule is occupying space. Take small amount of sugar. Sugar is filled in the one glass beaker. What amount sugar is filled in space also? No? Take a when balloon filled with air. Air also occupying space only. So any material which occupying space, it has mass and volume, is known as the matter only. Some other definition also here. Everything in this universe is made up of the matter only. Whatever the material you are taking in the universe, everything is made up of the matter only. Clear? If you take the table, chalk, sugar, water, air, whatever the material you take here, everything is made up of the matter only. So in this chapter, we are going to more focus on the matter only. So you know very well here, early age of time, scientists has been classified matter into 5 types. Is Panchatattva: air, fire, sky, earth, water, like that. So later on, scientists study about the matter. They want to know the properties of each and every matter. They want to study them better. They want to know what is the composition of matter. So based on this idea, matter has been classified into 2 types. One is a physical classification. Next one is chemical classification. In physical classification, matter has been classified into the solids, liquids, gas, plasma, Bose-Einstein. Clear is there now? So here in chemical classification, matter has been classified into the pure substance and impure substance only. Let's go to the basic idea about the matter. Properties of the matter. What is mean by properties of the matter? Certain properties of matter will be there. So what I mean, the matter is anything which occupies space. It has mass and volume. Okay. Next one, each matter is collection of a lot of tiny particles. Each matter is made up of a lot of tiny particles. We'll discuss example to get clear. Particles of matter are always continuously moving only. How can I say particles are continuously moving? Means you just imagine you just sat in the closed room with a dark room. You just make a small hole to the wall, a hole to the window, whatever maybe. When light comes, you can see dust particles are moving. Or else when you go for theater, when you go for your Saturn theater, whenever the focus light coming, you just see some dust particles are moving. It clearly indicates that particles are always continuously moving only. So once again, I'm saying matter is anything which occupies space. It has mass and volume. Each matter is a collection of tiny particles. Particles of matter always continuously moving only. So some physical nature of the matter only. The particles of matter are very, very tiny particles. Very, very tiny particles means we cannot see with our naked eyes. We can see with only electron microscope only. The particles of matter have space between them. So you have remember intermolecular spaces, intermolecular force of attraction only. What is intermolecular space means? Space between the molecules only. If you take any molecule, there sometimes space will be there. Just imagine take one matter. Any matter is made up of the molecules are there. The molecule having some intermolecular spaces. Here space is there. Okay, because of intermolecular space only you can dissolve the solids in the liquids only. Just imagine the particles of matter are continuously moving. The particles of matter are always continuously moving. The particles of matter is attract to each other. How can the particles of matter attract to each other? Just imagine I'm taking the one solid. The solids are tightly packed. Solids are tightly packed. So we need more amount of energy to break the solid particles. If you take liquids some more distance will be there. So if you take the gas molecules, a long distance will be there. So gas molecules are long distance will be there. So look at here. This one is based on the idea about the. Go for next slide here. You will get very clear. Next slide will get clear here. Just consider students here. I'm taking the particles having matter having the intramolecular space. Sorry, the particles of matter, tiny particles only. How can you say the particles of matter is tiny particles? Means no, just imagine I'm taking the here example you get very clearly. Here I'm taking a small amount of beaker, and this beaker I filled with equal amount of water. Here 100 ml, here 100 ml, here 100 ml, here also 100 ml. Initial what you will do, I did here, just I take small amount, for small amount of the KMnO for potassium permanganate crystals when I dissolve in the water. Because of excess amount of crystals are there, no, just consider initial when I take small amount, 2-3 crystals are there. When I stir the solution, initially water is colorless, it becomes pink color. From the solution, what I'm going to take 10 ml of water and dissolve in some other beaker and just stir the solution. When compared with these two, this is somewhat less intense in color. Again I transfer the 10 ml here, again I'll get the again here something is just consider here, I'm taking again here, just transfer again 10 ml of. What happens that just consider very clearly a color difference will be there. What is color difference means, you know very well, if you do it for 10 times also some color will appear. It clearly indicates what happens that here small amount of the potassium permanganate crystals made up of the millions of tiny particles of KMnO4. Because of that reason only KMnO4 can impact color to the solution only. Clear is there now? So dissolve 2-3 crystals of potassium permanganate in 100 ml of water and to transfer 10 ml of solution. Continuously transfer, which clearly indicates matter is made up of tiny particle. If it's not made up of tiny particle, KMnO4 is it cannot impact color. That's simple idea only. So when you go for the next one is here, when you go for next one is here. Okay, look at here, the particles of matter have space between them only. So take some water and a beaker and add sorry, take some, look at here, just mention that the particles of matter have space between them. I'm taking the water, you know very well the water molecule have some intermolecular space will be there. You can see very clear intermolecular space will be there. When it dissolves small amount of sugar, when I stir the sugar, what happens, the sugar will disappear. Here make a solution only, no. After look at here, just consider the level of this water, the level of this water also same only. So both are same only. It clearly where is events here, sugar is where when here, the sugar here, look at this water molecule has some intermolecular space is there. Sugar molecule occupy the intermolecular spaces, they make a solution only. This experiment clearly indicates here if most of materials made matter, the particles having intermolecular space between them. Clear only, no? Take some water in a beaker and notice level here, dissolve some salt, sugar. Look, you may add the salt or sugar, whatever maybe, the level is remaining fixed. It clearly indicates here that water have intermolecular space, the intermolecular space will fill with the sugar or water or salt only. So this is one example. When you go for next slide is then here you'll consider the particles of matter continuously moving only. How can the particles of matter continuously moving means I'm just taking the water, it is stagnant water. In the stagnant water when I add small amount of ink, I'm just doing without stirring anything else, just left the solution only. Initially what happens there, when I drop fall into the water, the droplet of the ink slowly disperse in the solution only. What is slowly dispersed in the solution means, you know very well, without doing any station, after few seconds you can see, after few hours you can see very clearly the total water has become blue color. Why this happen without stirring, you know how this color is dispersed in the solution. But your water molecules have some kinetic energy there. Because of the kinetic energy, water molecules are always continuously moving, they will impact color to enter the solution. This is the reason behind this one. Clear, the particles always move all the direction only. Clear. So what happens, this is one clear indication is the particles of matter always continuously moving only. Already given example is there now. Here is consider when you go for theater, when you see the screen light is coming, you can see the dust particles are always moving. This is also one of the example for the particles are continuously moving on. Particles are never moving in the rest only. Okay. Next go for the particles of matter attract to each other. This is very important. Suppose I'm just taking this is a solid, this is a liquid, this is a gas only. You can see that in the solid particles are tightly packed. They have strong intermolecular force of attraction will be there. Intermolecular force of attraction and tightly packed. Intermolecular space will be less. Remember, solids having high intermolecular force of attraction, less intermolecular spaces. Liquids having, when compared to solids, liquid having a less intermolecular force of attraction, high intermolecular spaces. Gases having very high intermolecular spaces. Intermolecular space nothing but the space between the two molecules only. The space between two molecules only. So what happens? They just imagine I'm taking one solid. Sorry, I'm taking one solid. Iron is just consider I'm taking one solid. To break the solid, I have to supply more amount of energy when compared to liquid and gas only. Clear? They have taken some example. They have taken iron nail. They have taken, and they have taken chalk piece, and they have taken one rubber band. They have taken. When first suppose I'm just taking the iron nail chalk powder. When I do with when I break with hammer, the chalk piece immediately break into powder. Immediately breaks into powder molecules only. Why? Because of means chalk piece you can also break with the hands also. So what happens? It clearly indicates in the chalk piece is in the particles having the less intermolecular force of attraction. When compared with the rubber band is there, no, you need more amount of energy. When compared with the chalk piece, we need more amount supply. We have to supply more amount of energy to break it only. Clear? When you go for iron nail, it's very difficult to break it. Why iron nail very difficult means iron nail having the strong intermolecular force of attraction. Iron is a metal, so this called a metallic force of attraction will be there. Because of metallic force of attraction, high iron having the high need a high more amount of energy to break the iron only. That's the reason why iron is used in the for the making of the doors, some window properties, something else, no. Okay, no? So sorry. So this is a major idea. The particles of matter attract to each other only. It's clear indication only. Clear, no? So when compared with iron, chalk piece and rubber band is iron have highest force of attractions only. When you go for one point, remember matters around a matter. Look at the area. Matter around us can exist in three states. Are there? Suppose I'm just taking the water. Water is exhibited in solid state, liquid state, and gaseous state. All these states are interconvertible into one form to another form only. Nothing but they are given in the matter around us is in three states. Okay, this is exhibited in three states only. So here next one is, let's go for the next one is area. Okay, the solid state only. You look at the solid state. One point, most important point is the property of solid having a definite shape and fixed volume only. Solid space between them, and look at the space between them particles are minimum. Look at the particles are very tightly packed only. The force of attraction between the particles are maximum. The particles are strong force of attraction. That is why they cannot move very freely. Okay, now next one is there. Now the momentum of particles are minimum only. Look at tightly packed. The particles are cannot move very freely. They are least compressible. Look at when you apply any force on this one is there now, because the tightly packed cannot be compressed only. The ratio of diffusion is least. Look what diffusion is the spreading only. If you take one iron nail, I'll just take one brick and place here. This cannot be move any position only. So diffusion process is very less in the solids only. When you come to liquids are there, no liquid. Just look at the liquid here. When compared with solid, liquids are very less tightly packed only. There are some intermolecular space will be there. Liquid have no definite shape and a fixed volume will be there. So you know very well solid have the fixed shape, fixed volume will be there. Here look at here, no definite shape will be there. Why no definite shape means if you take the water, when you place in the one bottle, look like the bottle. You place in one beaker, look like the beaker. You place in the glass, look like the glass only. So it doesn't have any space, any particular shape will be there. It appears the shape of the containers what we use. The space between the particles are intermediate only. It's not very strong, it's not very weak. Clear? The force of attraction between the particles are intermediate. The momentum of particles is intermediate only. In gas, particles are freely moves. In solid particles cannot move. Liquid molecules can move. How can the liquid can be flow? Means liquid can be flow from one place to another place only. This is one indication. Clear? They are less compressible. When compared with the gases, look at the gases can be compressible. You know very well LPG, liquefied petroleum gas, compressed natural gas. All the gas we can compress and we can place in the cylinder. But in the solids and liquids we cannot be compressible. The rate of diffusion is more than the solids only. Look at, just imagine solids cannot be spread easily, but when you pour the liquid on the any wall surface area, liquid easily flow. This one clearly indicates they can be diffused easily. Next one is gaseous state. Gases have no definite shape, no fixed volume. Okay, no, and it has fixed mass only. Gas occupy the whole space of the container. Suppose I'm just imagine I'm take the just consider that 1 mole of gas. It will occupy the same volume only. The space between them particles are maximum. Look at the particles having intermolecular space is maximum molecules are there. because the force of attraction between the particles are minimum only. Maximum intermolecular space means less force will be there. So the momentum particles are maximum. The particles are freely moves from one area to this direction, all directions can be moved. They are mostly compressible. You know very well gas can be compressible. When you take a balloon, when you apply the pressure on the balloon size will be decreases. Clear no? This is their ratio of diffusion is more in solid liquids. Just consider I am taking the gas. You want to know the diffusion process. Take one perfume bottle. When apply the perfume, apply the pressure. What happens there? The perfume will spread easily. Why? Because means in the perfume bottle, gas present at a high pressure. Gas molecule move from high pressure to low pressure through a small hole. The process called diffusion only. Clear is there no? So when you remember one point is there no? If you want to know about the solid, liquid, gas, I will say one thing. Solids nothing but in the classroom how our students sit properly. Liquids nothing but a breaking time. That break they have given you will move any place only. You can just gases sit nothing but in the hardest time. You can easily move any places only. Clear no? Solids, liquids and gases only. Next coming to the change in state only. I said one point is there no matter can be converted into another one form to another form by applying of the heat only. By applying of heat. When a solid is heated, it changes to the liquid. When liquid is heated, it changes to gas only. Suppose I'm taking one ice molecule. When I give the heat, it becomes liquid. The process called melting only. Whenever solid is ice is become liquid and heating is called as the melting process only. Liquid is become to gases. Remember, liquid is become to gas. Here two conditions are there. One thing is there now below its boiling point become to gases. One is at the boiling point become gas. Below its boiling point is evaporation. At its boiling point is called as a boiling point only. Now remember next one is that here what is the boiling point means the temperature at which vapor pressure of liquid equal to atmosphere pressure. The temperature at which vapor pressure of liquid equal to atmosphere pressure, or else some other definition is this. Okay, the temperature at which water starts boiling. Water boiling point 100 degrees Celsius only. So what I mean, they're just taking the gas molecule and cool the gas molecule, it becomes liquid state only. No? Suppose if you want to know this one is how can you, so just take this water is boiling only. No? Take small amount of ice cubes and when you place here, you can see small water droplets are present is there. No? Or else take the water bottle from the fridge. When you place outside, you can see the some water droplets around the bottle only. No? It clearly indicates no here undergo condensation, water undergo condensation only. Take liquid water bottle when you place in the fridge, what happens there and freeze it becomes solid only. No? Because this one is called as a freezing only. Okay, liquid to solid is called freezing only. So by this process, you know very well here, solid is become liquid on heating, liquid is become to gas on heating, gas become liquid on cooling, liquid become solid on cooling only. Okay, gas to liquid is called condensation only. Liquid to solid is called freezing only. Solid to liquid melting, liquid to gas evaporation and boiling only. Evaporation happen below its boiling point. Okay, this one only. Go for next one, students. Here melting or fusion. You know very well melting process means nothing but here whenever solid is heated, the particles are being to vibrated and the great speed and become to move more freely. Then at any particular temperature, the solid melts and changes into liquid. The process known as melting only. Melting nothing but the changes of the solid into liquid only. Here the temperature at which solids melts is called melting point only. Melting point of ice is nothing but 0 degrees Celsius. Other temperature units also used, nothing but kelvins, 273 kelvins only. Latent heat, what is latent means hidden heat only. Suppose I am taking the ice cube here, I am taking one ice cube here when I press thermometer. What happens, thermometer indicates 0 degrees Celsius only. But I can see very clearly here ice starts melting only. When I give in the heat also, it starts melting, the temperature remaining constant. Why temperature remaining constant? Nothing but when you supply the extra heat, the ice molecules takes the heat in order to break the work on the intermolecular force of attraction. So if I suppose if I take it, provide the 10 degrees Celsius, 10 degrees Celsius of the ice we utilize to become liquid state. That's only the temperature remaining constant. It's called latent heat of the fission, latent heat of the evaporation also is there. What latent heat means? The amount of heat energy required to change 1 kg of a solid into liquid at atmosphere pressure is known as latent heat of the fusion only. Fusion nothing but melting process nothing but clear latent heat. So the amount of energy required to change 1 kg of liquid into the 1 kg of solid into liquid is known as a latent heat of the fusion only. Next one is the boiling point. What is the boiling point? Remember here. Okay, when a liquid heated at particular temperature, the particles are slowly moves, and that it becomes liquid gas state only. The temperature at which liquid become to gas. That's called boiling point only. Or else we study in the higher classes the temperature which vapor pressure of the liquid equal to atmosphere pressure. Water boiling point is 100 degrees Celsius, or else you can mention as a 373 kelvins also is there. Latent heat of evaporation. Latent heat, hidden heat only, no. Suppose I'm just placing one thermometer. When it's in liquid without touching the ground wall, without touching the bottom of this beaker, when I boil the water, so how much amount of energy required to change 1 kg of liquid into gas at atmosphere pressure is known as latent heat of the evaporation only. Once again I'm saying the amount of heat energy required to change the 1 kg of liquid into gas, nothing but latent heat of the evaporation only. Boiling is a bulk phenomena. Why they call bulk phenomena means here, look at when you boil the water, all the area particles are starts boiling only. Not only surface area, not only bottom, entire the solution will be boils. That's called water boiling point is a bulk phenomena only. Okay. Next one is look at the effect of temperature. Look at the solid particles are there. When I give the here cold condition, when I give the temperature, the solid particles are space will be increased. This is called intermolecular spaces. Whenever intermolecular space increases, intermolecular force of attraction also decreases only. Liquid to hot condition. Liquid become to gaseous state only. This is also one of the example of the interconversion of the matter only. Remember here, most important thing you know very well, sublimation. What do you mean sublimation? The process in which solid state directly converted into gas state. Solid directly converted into gas is known as sublimation only. Clear? Suppose I'm taking the here naphthalene. I'm just doing one. Okay, here funnel. I'm just taking funnel. In this funnel, I'm taking ammonium chloride. Ammonium chloride one crystal solid. It undergoes sublimation. You can take the naphthalene balls also, sodium also, iodine also, whatever the materials are there. On heating, without converting liquid state, it directly converted into the gas state. That's called sublimation. They have taken this called China dish. In this China dish, they have placed ammonium chloride. They have taken the here funnel, inverted funnel. They will take here. They will place here cotton here. Why they are placing cotton means to prevent the escape of the ammonium chloride vapors only. When heated, what happens there? The solid is become to vapor. The vapor molecule slowly become to appear here, and the time comes here. The solid particles settle at the walls of this funnel undergo condensation, become solid, again solid only. So initial what happens then? Initial no solid ammonium chloride solid will be here. The time goes on, the amount of ammonium solid will be increased only. Clear? This is nothing but a sublimation process. Sublimation nothing but whenever solid is heated, it will become to get gas without liquid state. This is called sublimation only. Clear? Next one is here. Go for look at here. Interconversion of matter. Solid to liquid is called fission. Solid to liquid is called fission. Liquid to solid is called solidification or freezing. Anyone you can take also, no problem. Liquid to gas, vaporization or evaporation. Gas to liquid is called condensation. Look at the solid to gas sublimation is called solid to gas sublimation. Gas to solid also called as a sublimation only. Clear? Gas to solid as sublimation, solid to gas as sublimation only. So next one is effect of pressure on the gases only. When the pressure is applied on the gas particles, they come to close and the gas changes to liquid state only. Suppose look at I'm just taking the gas molecule. I mean temperature is fixed temperature. When I apply the high pressure, low temperature, gas becomes liquid state only. That's nothing but LPG, liquefied petroleum gas. When I apply high pressure, here LPG becomes liquid state only. Clear is there now? One point remember, if you want to convert gas into liquid, low temperature, high pressure. If temperature more, the gas never becomes liquid state only. Then it will compressible. Generally carbon dioxide gas they will use for compressible process. This is also called as a dry ice. Okay, the carbon dioxide is called as a dry ice only. Next, coming to the next slide here, look at the evaporation only. What is evaporation here? The change of a liquid into vapor at any temperature below its boiling point. We have called evaporation. Evaporation surface phenomenon. Why they call surface phenomenon? Means more surface area is there, more rate of evaporation is there. We studied in the previous classes. If you take the one cloth, the wet cloth, when the folded form, it takes more time to dry. When you spread more area, it easily becomes. Or also, if some people they will clean the floor, they will clean the floor and they will spread the water. Clear? Rate of evaporation increases. Okay, what is this evaporation? Surface phenomenon. The rate of evaporation depends upon the surface area, temperature, humidity, and wind speed. When surface area increases, rate of evaporation increases. Temperature increases, rate of evaporation increases. Humidity increases, rate of evaporation is decreases only. You know very well in the rainy season the clouds takes more time to dry up. And wind speed. Suppose you know very well whenever water flow on your floor, you just switch on the fan, it easily dry up only. Okay, increase surface area, rate of evaporation increases. Increase temperature, rate of evaporation increases. Increase humidity, rate of evaporation is decreases. Increase the wind speed, rate of evaporation also increases. Okay, evaporation of causes cooling only. You know how we say evaporation causes cooling means, just imagine when the person is running in the, just went for jogging something close, you get very sweat. Just stand near to the fan, how you feel? Cool only. You know why is feeling cool? Because whatever the sweat will be there, sweat molecules takes energy from the body, it undergoes evaporation. Evaporation endothermic phenomena. Endothermic phenomena causes coolingness only. That's the reason why he feel like that, cooling only. Look at when a liquid is evaporates, the particles of liquid absorb heat from the surroundings and evaporates. So the surroundings becomes the cold. People sprinkle water on the roof only. Why they're sprinkling water on the roof in summer season? Because of nothing but here the water evaporates. Whenever water evaporates, the water molecule takes heat and gives the cooling process only. Clear? During summer we sweat more because of during the evaporation the sweat absorb heat from the body and make the body is cool only. You know very well here same phenomena. Whatever you look, wearing of cotton cloths in summertime. When you wear the cotton cloth, what happens? The cotton cloth absorb the sweat. When you take an evaporation, it causes cool. That's the reason why you're using the cotton cloths in the summertime only.